Alrighty guys, so this is the intro flipped homework, the very first one, to our next unit, which is expressions and equations. So the difference between an expression and equation is that an expression is a numerical phrase. And we say it's a numerical phrase because it doesn't contain an equal sign. An equation does include an equal sign, and we call that a numerical sentence. So on your foldable right here, we are looking at an expression. And it is an expression because it lacks an equal sign. So we're going to go ahead and label it on your foldable that this is an expression, and it is a numerical phrase that does not contain an equal sign. And I'll just underline that real quick because I like it. All right, expression, numerical phrase that does not contain an equal sign. The key there is that it does not contain an equal sign. Now, we're going to talk about different vocabulary that you will need for this upcoming unit. I'm sure that you've heard these before, and if you have, I want you to take a moment and pause this video and try to remember the definitions for coefficients, constants, terms, and like terms. Then resume the video, and if you think you're right, you can kind of fast forward and see if you were right. If you're not, or you have no idea, just stick right here with me. Okay? All right, coefficients. The definition of a coefficient is, I'll start it over here, a number used to multiply a variable. I'm just going to make this better. To multiply a variable. It's a number used to multiply a variable. Notice a coefficient isn't really division because division can always be written as a fraction. So let's talk about this expression that we have right here. This expression we have right here has coefficients within it. Now we need to look and say, okay, I know that multiplication in math is the only indivisible operation. So the only indivisible operation here exists right here between the 9 and the x squared. Right here between the 7 and the x. There's an invisible number right here we're going to talk about, and this number right here. Basically, if you have a variable, you have a coefficient. So where there's a variable, there's a coefficient. Let's start listing them. So first and foremost, we have this term. 9 is our coefficient because it's a number that's being multiplied by the variable. So we have 9. Next, 9. The next one would be 7. Now, this is important to talk about. The operation that is in front of the coefficient determines whether or not it's a positive or negative. Since it's plus 7, that means that we have a coefficient of positive 7. I'm going to skip this one and come over here. This coefficient, because of the minus sign, wouldn't be positive 4, but it would be negative 4. Now I'm going to pop back here, right there. What's the only invisible number in math? The only invisible number in math is 1. So there's an invisible 1 times x here that you don't see, but you need to know is implied and is always existing. So 1 is our final coefficient. All right, let's talk about constants. Constants are a fixed value. In other words, it's a number that stands alone. A number that stands alone. And what I mean when I say is that it stands alone is that it doesn't have a variable with it. That means it is a number that lacks a variable. And we'll go ahead and color code this because I love color coding things. So it's a number that lacks a variable. Well, let's go through. Well, I got a variable there, got a variable there. Oh, I don't have a variable here. I have just a 2 that stands alone. And I know the sign in front, the operation is going to determine whether or not that's a positive or a negative 2. So therefore I know one of my constants is negative 2. I'm going to check. No, that's got a variable. Oh, I'm at another number that doesn't have a variable. And the sign in front tells me that this is going to be a positive 5. So in this particular expression, I only have 2 constants. Now let's talk about terms. Terms. Definition of a term are, well, terms are separated. by addition or subtraction. So what I tell my students to do when they're trying to decide how many terms, and we will ask you that, we will ask you how many terms are in an expression. To determine the amount of terms in an expression, you simply need to separate out your additions and subtractions. So I just tell my kids, okay, go through the expression and put a line in front of every addition or subtraction, not behind, but in front. And the reason is, just like I said before, each number takes on the operation in front of it. So like I said, this is a -4, that's a +5, that's a +1. So those operations actually indicate signs, whether it's positive or negative. Now I need to count my terms. So I've got 1, 2, 3, 4, 5, 6. So I've got 6 terms here. 6 terms. You will be asked to identify the number of terms, the coefficients, what the constants are, and then you'll be asked to talk about like terms. I'm going to go ahead and move myself up there. Like terms. Like terms are exactly what they sound like. They are things that look alike. So like terms are terms that are like each other. And what that means is that they have the same variables with the same exponents. So that means that they have to look identical. Their coefficients could be different, but the variable terms themselves have to be the same. So x squareds with x squareds, x's with x's, x cubes with x cubes, y's with y's. And of course, if they don't have a variable, if they're a constant, constants are like terms with constants. So let's go ahead and discuss our like terms. I would like for you guys to set up a little table for yourself to identify the different types of terms you have. Now, I already know we're going to have 3 different types, so I'm going to break it up there. Type number 1 will be, let's start at the beginning, x squared terms. So we're going to put x squareds here. Now we're going to list our x squared terms. So we have 9x squared. Oh, that's bad. I'm going to redo that. X squared. Sorry, I'm writing with a computer mouse. Then I say, okay, I've got 9x squared, 7x. Oh, that's not an x squared, so it doesn't go with x squared. -2 doesn't have an x squared either, so it doesn't go with the 9. Neither does the x, the 5, but aha, I'm here at the -4x squared, and I write it exactly as shown. -4x squared. So those two are like terms because they both share an x squared. Now let's say, okay, now I've got my 7x. So let's just go ahead and say I'm looking for all x terms now. So I have 7x. What other x terms do I have where the x stands alone? The answer is I've got the plus x. So I'm going to have plus x. And last but not least here, I'll use orange, -2. This is a constant. So I'm going to put C for constant. Better C. C for constant. You get what I'm saying. So here I'll write my constants. So -2, and the only other constant is a +5. So here I have listed out my constants, my x terms, and my x squareds terms. So I got all the way to the end, and I realized that we forgot to label our initial expression. So pause the video right now, label these expressions on your paper, and see if yours matches mine. Alrighty, check your answers. You got coefficients, variable, and constants. Hopefully you did it right. And now you will actually go into the activity that you're going to do on Google Classroom as practice identifying different parts and what are and are not like terms. Thank you.